Welcome to the Check Your Understanding for 6.2b. This is going to be a good one. A large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X equal the number of cars sold and Y the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distributions of X and Y are as follows. So we see them here. The cars sold could be 0, 1, 2, or 3. The cars leased could be 0, 1, or 2. And then their probabilities, you've got the mean and the standard deviation there. So define T, so T like the total of cars both bought and leased, equal X plus Y. Assume that X and Y are independent. Find and interpret the mean. So we know when you have independent random variables, the sum of them for that distribution, you can just add the means. So we can find the mean. Mean of T is the same as that sum, 1.8. And here's the interpretation more importantly. Over many, many Fridays, the dealer expects to sell and lease on average about 1.8 cars. So over time, make sure you have that in there. Calculate and interpret the standard deviation. So remember, one does not simply add standard deviations. You can't just do 0.943 and 0.64. You have to square them, add the variances, and then take the square root. So this is a sigma. Sigma sub t equals the square root of sigma sub x squared plus sigma sub y squared. And then you can see that work, and it's 1.14. So that's number of cars. Here's your interpretation. The number of cars, sales, and leases typically varies from the mean of 1.8 cars by about 1.14 cars. The dealership manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Nice. Find the mean and standard deviation of the manager's total bonus. So you want to transform first and then combine. So you can take that probability distribution for cars sold, and instead of thinking of in terms of cars, it's money. So if you sell 0 cars, you'll get 0 in bonus. If you sell 1 car, you'll get 500, 2 cars, 1,000, 3 cars, 1,500, etc. So here's the work for that. So we're going to transform the means so that 1.1 cars is now multiplied by 500, so 550. And then plus the $300 for the average of 0.7 cars leased, 760. The standard deviation, you do the same where you scale it up because you're converting basically from cars to dollars and then finding the standard deviation. You wouldn't want to just take like the mean of distribution T and multiply by 800 because it's different. That $500 occurs a different amount than the $300. So transform first, combine second. Okay, now if that wasn't enough for you, we got this apples problem. Suppose that a certain variety of apples have weights that follow a normal distribution with a mean of 9 ounces and a standard deviation of 1.5 ounces. If a bag of apples is filled by randomly selecting 12 apples, what is the probability that the sum of the weights of the apples is less than 100 ounces? So the reason, we're in school, it's period 8. So the reason why we're not just going to take the mean of 1.5 and multiply by 12 and take the standard deviation and multiply by 12 is I don't have like a single random apple that's 12 times as big. I'm selecting 12 different apples, and each one of those selections is a random event. I don't know if you can hear that banging. Somebody's banging next door. Okay. So first off, define your random variable. X is the weight of a randomly selected apple. So X of 1 is that first apple, and you would go all the way down to X of 12. So T is going to be that total weight. So the sum of the weights of all the apples. So we want to know the mean of T, that total weight, and the standard deviation of that total weight, which we know will be normally distributed because when you combine random variables, whether it's with a sum or a difference, and they were normal, the sum or difference will also be normal, that the distribution of the sum of the weights or difference of the weights, whatever you're doing. So like I said, T follows a normal distribution. To find the mean, you would add the mean of the 12 different variables, 12 times. So 9 plus 9 plus 12 times, or 9 times 12. So this case, like, technically adding 12 times is the same as multiplying by 12. However, with the standard deviation, it's not the same as multiplying by 12. It's actually going to be the same as multiplying by root 12. So the standard deviation for that total, you would add all the variances. So all 12 variances, 1.5 squared. And you end up with the square root of 27, which is about 5.2 ounces. So this is for our distribution of the total sum, all 12 apples in a bag. And you want to find the probability that that total weight would be less than 100 ounces. You could do less than or equal to, it doesn't matter. Remember, you can't find the probability of exactly 100, it would be 0. So you can turn that into a z-score, take that value, subtract the mean, divide by the standard deviation. So the z-score is negative 1.54. Find that on table A, find the area to the left of it, or use a calculator. Make sure you draw your sketch, label your parameters, and show all the necessary work. So you could use table A or the correct normal CDF justification, making sure you label what the lower is, the upper, the mean, and the standard deviation. And you should get that the area under the curve here is 0.0620, but you know we'll never answer a problem without doing it in context. So here we go. There's about a 6.2% chance that the 12 randomly selected apples will have a total weight of less than 100 ounces.